I, Amrin Shabir Chaudhary, lecturer in Arihant Junior College of Arts, Commerce and Science, Camp Pune. My today's topic is Differentiation Part II. Geometrical meaning of derivative. Consider a point P on the curve f of x. At x equal to a, the coordinates of P are a f of a. Let Q be another point on the curve a little to the right of P, that is to the right of x equals to a, with a value increased by a small real number h. Therefore, the coordinates of Q are q of a plus h, comma f of a plus h. Now we can calculate the slope of the second line PQ, that is slope of the second line connecting the points P of a f of a and q of a plus h, comma f of a plus h. By using formula for slope, slope of second PQ equals to f of a plus h minus f of a divided by a plus h minus a, that is equals to f of a plus h minus f of a divided by h. Suppose we make h smaller and smaller, then a plus h will approach a as h gets closer to 0. Q will approach p. This is as h tends to 0. The second coverage is to the tangent at p. Therefore, limit q tends to p, slope of second pq is equal to limit h tends to 0 f of a plus h minus f of a divided by h, which is equal to f dash a. So we get slope of tangent at P equals to f dash A if limit exists. Thus the derivative of a function y equal to f of x at any point P of x1 y1 is the slope of the tangent at that point on the curve. If we consider the point a minus h to the left of a, h greater than 0, then with r equals to a minus h, comma f of a minus h, we will find the slope of PR, which will also coverage to the slope of tangent at P. If y equal to x square plus 3x plus 2, then slope of the tangent at Q3 is given by slope equals to m equals to dy upon dx, which is equal to derivative of x square plus 3x plus 2, which is equal to 2x plus 3. Now substitute the value xy as 2, 3. Therefore, we get m equals to 7. Derivative of inverse function. We know that if y equal to f of x is a 1, 1 and onto function, then x equal to f inverse y exists. If any f inverse y is differentiable, then we can find its derivative. In this section, let us discuss the derivative of some inverse functions and the derivatives of inverse trigonometric functions. Example, consider f of x equal to 2x minus 2. Then its inverse is f inverse x equal to x plus 2 upon 2. Let g of x equal to f inverse x. If we find the derivatives of these functions, we see that derivative of f of x equal to 2, derivative of g of x equal to half. These derivatives are reciprocals of one another. Suppose y equal to f of x is the differentiable function of x on an interval L and y is 1, 1 on 2 and dy by dx not equal to 0 on L. Also, if f inverse y is differentiable on f of L, then dy by dy f inverse y equal to 1 upon f dash x, or dx upon dy equals to 1 upon dy by dx, where dy by dx not equals to 0. Proof. Given that y equal to f of x and x equal to f of f inverse y are differentiable functions, let there be a small increment in the value of x, say delta x. Then correspondingly, there will be an increment in the value of y, say delta y. As delta x and delta y are increments, therefore delta x not equal to 0 and delta y not equals to 0. We have delta x upon delta y into delta y upon delta x equal to 1. Therefore, delta x upon delta y equals to 1 upon delta y upon delta x, where delta y upon delta x not equals to 0. Taking the limit as delta x tends to 0, we get limit delta x tends to 0 delta x upon delta y equal to limit delta x tends to 0 1 upon delta y upon delta x. As delta x tends to 0 and delta y tends to 0. Limit delta x tends to 0, delta x upon delta y equals to 1 upon limit delta x tends to 0, delta y upon delta x. This is equation 1. Since y equal to f of x is a differentiable function of x, we have limit delta x tends to 0, delta y upon delta x equal to dy upon dx and dy upon dx not equals to 0. This is equation 2. Now from 1 and 2 we get limit delta y tends to 0, delta x upon delta y which is equal to 1 upon dy by dx. This is equation 3. As dy upon dx not equal to 0, 1 upon dy by dx exists and is finite. Therefore, limit delta y tends to 0, delta x upon delta y, which is equal to dx upon dy, exists and is also finite. Hence, from 3, dx upon dy equals to 1 upon dy by dx, where dy by dx not equals to 0. Thank you everyone for watching my video. Thank you.